Hello, I'm Addison. I'm a part of the Bioretention team in Green Campus Enterprise. This team is sponsored by MTU Grounds. For this presentation, we will first be going over the background of this project, then our goals for the semester, how and where we decided to implement this project, the watershed delineation we performed, and then finally we'll be going over the budgets for both the soil and vegetation needed to build the rain garden. For the background, the main goal of this team is to help alleviate flooding on Michigan Tech's campus by designing and installing rain gardens. Reducing some of this accumulating water will help improve the walkability and overall aesthetic of campus, as well as decreasing the amount of runoff helps protect the Portage water quality. For our goals for this semester, we were really hoping to design a rain garden to install on campus, acquire funding, and prepare to build a rain garden in the fall. And for the goal of finding a place to install it, there were really many areas on campus that experienced water buildup. Our team identified 7 specific locations where a rain garden could work. Soil testing was completed at all these locations to determine soil health. For the first garden being built, the best location was just south of MTU's football field. This location is near to the football VIP seating area and close to the new ambulance garage. The location experiences flooding and is the most convenient location when working with MTU grounds. And this showcases the area we decided on, and we are currently using 2 400 square foot gardens, and that's what's indicated by the 2 orange circles. The size of the exact location of the rain gardens were determined using the tool ArcGIS Pro. With this software, we were able to determine the low points where water pools and how large the watershed for that specific point was. The area of these watersheds were then put into a spreadsheet prepared by the Michigan Department of Environment, Great Lakes and Energy, EAGLE for short, to predict the water flow for a 100-year storm. The team was able to modify the spreadsheet to predict a 10-year storm. The team was able to create a rain garden based on the amount of water it should store in these storms. Yeah, and that is indicated on this slide here. Next up was the soil budget. So the rain garden will require soil amendments. Our goal for this soil composition is 50% sand, 30% topsoil, and 20% compost. We won't have to purchase sand because the soil consists mainly of sand. However, we will need to purchase topsoil for $293 and composted leaves for $355. MTU Grounds is providing delivery and leaf mulch for the top 2 inches of the rain garden. For the vegetation, for the total 800 square feet, we found that 342 individual plants will be needed. This is assuming we plant each one 18 inches apart. We chose Designed by Nature in Marquette to purchase our plants from because they are a UP native nursery, and you can buy flats instead of just individual plants, where each flat contains 38 plugs or starter plants, and we will be purchasing a combination of 7 single species flats and 2 mixed flats. Purchasing in bulk like this will save us some money, but will still allow us to have a wide variety of plants. These 9 flats will cost $635 total. And this is a diagram showing what the vegetation will look like when it's implemented in the garden. The plants we're currently planning on using are switchgrass, Joe Pye weed, swamp milkweed, turtlehead, marsh blazing star, New England aster, bog goldenrod, great blue lobelia, wild blue iris, blue vervain, and monkey flower. And then this is what a profile view of the rain garden will look like. It's just breaking it down by like where the just overall ground is, and then versus where the soil we're putting the rain garden in will be. Thank you for your time.